Good afternoon, everybody. Welcome to sunny Monday afternoon of Chem 1105 with your host, me, Dr. White. Hi. Hi, we got a busy week this week, so let's get to it. Now, let me remind you, this Thursday, the 13th, I will be giving test number 2 online. You'll get a password protected file uh, uh, email from me with the password for the PDF file of test number 2 that you'll be able to download from the assignment area. You'll have until Friday, 4 p.m. to finish test number 2 and upload your answers. This is important as a single PDF file to the assignment area of Blackboard. It should take about 40-45 minutes for you to finish it if you studied, but take up to 2 hours or so if you need it. All right, as I've already mentioned, test 2 will cover chapters 4 and chapter 5, part 1. This includes or will cover chemical bonding, including ionic covalent chemical bonds, and I'll cover mole and mole-related topics, including balanced chemical equations. I think there are 3 or 4 of those on the test. Oops. All right, test has 18 problems, 9 pages. There are no multiple choice, but some of the questions are multiple part. It will have 50 points on chemical bonds and related topics. It will have 55 points on mole and mole related topics, including balanced chemical equation. And that adds up to 105 points. So there is five bonus points. All right, you'll need a scientific calculator. I reserve the right to subtract up to 50 points for anyone who doesn't follow instructions or anyone who does not upload your test answers on time as a single PDF file. And the rest by next Sunday or earlier, I'll post your grades in Blackboard. I'll also send out an email with your individual points on Monday after test number 2. I'll go over the test answers in our Zoom meeting, but I will delete it. I like those special effects. I will delete it from the video, but I'll post it as a private video, and I'll send you the URL for that private video. Now, tomorrow I will do, let me take this up. Tomorrow, it's going to be a real busy day. We'll have our lab, and then I'll do the review for test number 2, and then I'll go through chapter 5, part 1, problem set. Now, that's a lot, so I may tomorrow, which I rarely ever do, but since we're on Zoom and most of you are watching it anyways on YouTube, thank you for making me a YouTube star, really. Anyways, I may go a little longer tomorrow because I want to finish everything up, give you time to look at it. All right. One other thing I want to mention. A lot of you, shame, have not been handing in labs. Hand in labs. You don't, you're going to lose 10 points. You lose 5, you don't do 5 labs, you lose 50 points. 1, 2, 3, 4, 5, 50 points. And losing a lot of points can drop you 1 or more letter grades at the end of the semester. So hand in the labs. If you're having a problem with labs, come to my office hour. If you're working or something like that during my office hours, email me and I'll see when we can set up a private Zoom meeting so I can help you get labs handed in. The Carolina Lab Kit is a really good one. And yes, it does take time to do the labs. And if we were face-to-face, we'd be in a 3-hour lab period once a week in the fall and spring. In the summer, twice a week, 8 hours or 6 hours, I mean. All right. Now, Let's continue where I left off last week. I was talking about mass calculations for reactions, and this is a three-step calculation finding moles or mass, usually it's mass, which is grams of a substance in a chemical reaction. Now, the three steps are: one, whatever you're given the weight of mass, you convert to moles, which you should know how to do by now. We've done a number of those. Next, convert the moles of whatever you just calculated into moles of B. Let's see what you're trying to get to the substance, and then convert the moles of B to mass of B, grams, and you know how to do that. So let's do two more practice problems. Tomorrow, I'll go through the practice problems. All right, where did I hide it? Ah, here it is. That's why I never opened it. Hold on one second. I'm looking for my whiteboard and I never opened it. Oops. All right, let's do some practice problems using the three-step method. For those who came in late, watch the video. Also, I talked about test number 2, and don't forget the hand in your labs. All right, let's do the following. And just hang in there if you were we were face to face. You'd be watching me do this on a whiteboard, just like you're doing, watching me write it now. All right, let's go through this. How many grams, that's G is grams, of ammonia and H3 are produced when you react 8.671 grams hydrogen gas, that's H2, with an excess of nitrogen gas? So the first question is, also you're given this balanced chemical equation. That's important. And 10 points. Whoa, that's important too. All right, so how do we begin? What are you being asked to find? How many grams of ammonia? What are you given? 8.671 grams of hydrogen. Now, when you see excess of a chemical, that means you can ignore it. I like my fancy hand signs, ignore it, ignore it. So we will. You're also given this balanced chemical equation, which we'll get back to. There's no way I can go from grams of one compound to grams of another in one step. You can't. You can try and I'll mark you wrong every time. So we need 3 steps. And this is something you should know for test number 2. And in case you forgot, what are the 3 steps? If you go to important information, test number 2, you'll be given this. Here are your 3 steps. Step 1, mass of A, which means grams, convert to moles of A. What's A? Well, let's find out. Well, the only thing we have to start with is hydrogen, and that's A, compound A. So in step 1, we want to go from grams of A, which is hydrogen, to moles of A, which is still hydrogen. So the only thing we have to work with is this. And what units do we want our answer in? Well, in step 1, we want moles of hydrogen, H2. And now it's time to use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of this conversion ratio. Whatever you're trying to get rid of goes underneath. And I'll write that in. Now, the question is, where do we find a relationship between moles of a compound and grams of a compound? Good question. Thank you. I ask good questions, don't I? Don't answer that. And if you go to important information, test number 2, you'll see 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights, which makes me say, oops, I better open up my periodic table. So in order to get a relationship between moles of hydrogen and grams of hydrogen, I need the molecular weight of hydrogen gas, H2. Well, that's the sum of all atomic weights. So I need the atomic weight of hydrogen, which you can find on your friendly neighborhood periodic table. The green one you see on the screen. Now, on test 2, underneath your name, it will say, please use proper significant figures for all calculated answers, and it will say, please use 3 significant figures for all atomic weights. If you don't, I'll take off a point for each problem you don't. So 1.008, round that off to 3 significant figures, keep the 1, keep the 0, keep the 0, that's my 3, use the 8 to round off, and that's 5 or higher. So I'll drop that, and the number in front I increase by 1. So the atomic weight of hydrogen, remember, for every 1 mole of hydrogen gas, we need the molecular weight of hydrogen. And the molecular weight hydrogen is 2 hydrogen atoms. That's what this means. And each one is 1.01, which means it's 2.02. This is an exact number, 3 significant figures, 3 significant figures. And now we'll look before we pick up our calculator. Actually, I'm grabbing for it. Your units cancel out to give you the right answer unit-wise. Notice grams of hydrogen divided by grams of hydrogen. anything divided by itself equals the number 1, cancels out. So this cancels out. We're left with moles of hydrogen. That's what we want. And now I'll pick up my calculator, clear it, 8.671 divided by 2.02. And my calculator gives me this huge number, not huge, but highly significant number, which my calculator doesn't know significant figures. And says times 10 to the 0. Remember, 10 to the 0 equals the number 1. So you don't have to write this down at that point. Now, when you do a multiplication division, you get the same number of significant figures in your answer as the number that has the fewest significant figures. This has 4 significant figures. All non-zero numbers are significant. A 0 after a decimal is significant, so this has 3. And this 1 is an exact number, plays no role. So the answer should have the same number of significant figures as the number with the lowest significant figures, which is lower, 3 or 4. And hopefully you all pick 3. So I'm going to round this off to 3 significant figures. Those are my 3. Use the 2 to round off. That's 4 or less. So I'm going to just drop all this. And for step 1, my answer is 4.29 moles of hydrogen. Now, one thing I always do, but I haven't pointed out, when you're doing these problems, 1, it pays to show your work. And I mentioned that last Thursday. But 2, don't forget to write in the units here. That will help you. Well, we've done step 1. It's time to do step number 2. In case you forgot, what's step number 2? Well, we'll go to important information, test number 2. And test number 2, step 2, is convert moles of A to moles of B. Well, what's A? What's B? Well, A is the hydrogen. So we want to go from moles of hydrogen, that's our A, to moles of what we're trying to get to. And that's ammonia. And so we just calculated, we have 4.29 moles of hydrogen. We had a ratio. We convert it to what answer, unit-wise? Moles of ammonia. And now you use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And now I'll write it, moles of NH2, NH3, sorry about that, and moles of hydrogen. And where do we get that ratio? Moles of hydrogen, moles of ammonia. I'll wait until everybody's finished copying. You finished? And we come up to the balanced chemical equation. The coefficients, the number in front, gives us molar relationships. When there's no number, it's the number 1. This tells me there are 3 moles of hydrogen reacting with 1 mole of nitrogen to make 2 moles of ammonia. So what's my relationship? Moles of hydrogen to moles of ammonia. For every 3 moles of hydrogen, I make 2 moles of ammonia. And we get that from the coefficient, the number in front of the formula. So I now know for every, and just in case you forgot, you can go back up and peek, and I will, for every 3 moles of hydrogen, we got that from up here, how many moles of ammonia? I almost went like that, like I was face to face. You won't see it if I go like that. What is he pointing at? Well, anyways, the 2 moles of ammonia. Now, before I pick up my calculator, notice moles of hydrogen divided by moles of hydrogen. Anything divided by itself equals number 1, meaning it cancels out. And I'm left with moles of ammonia. Now, if you had that upside down, you'd have moles of hydrogen times moles of hydrogen divided by moles of ammonia. And that would be the units of your answer. And I sure don't want that. So it's important to check that your units really cancel out. Just don't put lines through it. And now I can pick up my calculator. 4.29 times 2 divided by 3. And my calculator gives me, oh, it's nice to me today, 2.86. Now, let me remind you, you get the same number of significant figures in your answer as the number that has the fewest significant figures. This is 3 significant figures. Coefficients are exact numbers, which play no role. And my answer, oh, my calculator was nice, gave me 3 significant figures. Now, am I done? Well, let's look. My answer right now in step 2 is moles of ammonia. But I'm trying to get grams of ammonia. So I'm not done. What do I do? And now you know why this is 10 points. It's a lot of work. All right, step 3, and in case you forgot. Step 3 is to convert moles of B to grams mass of B. Moles to B to grams of B. What's B? Whatever you're trying to get to. And that would be, we're trying to get to grams of ammonia. So we just figured out moles of ammonia. We want to get to grams of ammonia. And the only number I have to work with moles of ammonia, I just calculated. If you had some ratio, something over something, what units do you want your answer to be in? Well, it says it right here, grams of ammonia. And you know what I'm going to say? Yep, it's time to use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And I'll write those units in. And the question is, where do I find a relationship between grams of a compound and moles of a compound? And in case you forgot, 1 mole of a compound equals the molecular weight of that compound. The molecular weight of that compound is the sum of all atomic weights. Well, I better go look at my periodic table, because hydrogen, I'll need 3 of those. Well, I know that's 1.01, the 3 significant figures, but I need 1 nitrogen. And here it says 14.007. Why don't you round that off to 3 significant figures? Because on test 2, it'll say, please use 3 significant figures for all atomic weights. Time's up. Keep the 1, keep the 4, keep the 0. Second 0 used to round off. Is that 4 or yes? It is. So I drop that 0 into 7. And the 3 significant figures, the atomic weight of nitrogen is 14.0. And remember, 1 mole of a compound equals its molecular weight in grams. So I now need the molecular weight of ammonia. That's 1 nitrogen and 3 hydrogen. Each nitrogen is 14.0. We just saw that from the periodic table. Now, earlier, we found each hydrogen, there are 3 of them, is 1.01 atomic weight. Do the math, multiplication, and now add these up. Now, you get the same number of significant figures to the right of the decimal, and all numbers to the right of the decimal are significant, as the number you're adding up that has the fewest significant figures. This has 1. This has 2, which is smaller. I hope you all pick 1. So I should have 1 past the decimal. This is my 1. Use this to round off. It's 4 or less. So I'm going to drop it. So the molecular weight of ammonia is 17.0. So for every 1 mole of ammonia, there's 17.0 grams of ammonia. Now, before I pick up my calculator, notice here I have moles of ammonia divided by moles of ammonia. Anything divided by itself equals the number 1, cancels out. This cancels out. I'm left with, yay, grams of ammonia. And now I can pick up my calculator. 2.86 times 17.0. And my calculator gives me this number. And you could have also written down 48.62, but most of you will be in scientific notation. Now, once again, when you have multiplication division, you get the same number of significant figures in the answer as the number that has the fewest significant figures. 3 significant figures, 3 significant figures, exact number. Therefore, my answer should have 3 significant figures. I'll give you 3 seconds to figure out what that is, then I'll do it. Which I'll give you more than 3 seconds. I'm going to take a water break. Correct. Person who gave the right answer, keep the 4, keep the 8, keep the 6. Use that to round off. It's 4 or less, so I'll drop it. And my answer is 4.86 times 10 to the first grams of ammonia. And that's how you do it. Now, time for Dr. White to go on an ego trip. Ego trip time, look out. I've done those type of calculations, and later in the semester, I'll have a special surprise for you about a chemical plant, but I can't talk about it now. But I have done those calculations where I'm doing it for hundreds of thousands of pounds of chemical and hundreds of thousands of dollars for those chemicals. And you don't want to make mistakes. I never did, never have, and hopefully never will. All right, let's do another one. All right, let's look at this. 10 points. You're given a balanced chemical equation right here. And that's propane, C3H8, reacts with O2, oxygen gas, to make carbon dioxide, CO2, plus hydrogen. Oops, I forgot something here. Plus water. Ooh, that would have been bad. And I made a mistake. Yep, no, I got it right. All right. So the first thing I'm going to ask you to do stepwise is, what are we being asked to find and what are we given? Your turn. All right. Everybody's done, so it's my turn. We're trying to find how many grams of propane. C3H8. What are we given? We're trying to make 61.7 grams of CO2. Now, when you see an excess of oxygen, that means you can forget about it, and it doesn't say anything about water, so you can forget about that too. So, how do we proceed? Notice you're trying to go from grams of one compound to grams of another. That's what the G is. You can't do it in one step. You need 3 steps. In case you forgot, here are the 3 steps. Step 1, mass of A to moles of A. Step 2, moles of A, now that you just calculated, to moles of B. Step 3, moles of B, you just calculated in step 2, you convert to mass, meaning grams of B. Oop, wrong. All right, let's do this stepwise. Why don't you try and you set up step 1 on your own, then I'll do it. You don't have to do the calculation. Just what are you starting with? And what's your units of your answer? And what's the ratio? All right, looks like everybody's done. Let's find out if you did it right. Now, what's A? Well, whatever you start with that has the number, the grams, and that would be CO2. So we have 61.7 grams of CO2. We want to get to moles of CO2. And now you use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Remember, I told you I was going for the Guinness Book of World Records for saying your good buddy, your good friend, unit analysis the most times a semester. I hope somebody's keeping count. That goes on top. That goes on there. And where do we get that relationship of moles of a compound and grams of a compound? Well, if you forgot, you can look at important information. Test number 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in the compound. Well, CO2, carbon dioxide, has carbon and oxygen atoms. And remember, on test 2, we'll say, please use all atomic weights to 3 significant figures. And for carbon, that's 12.0. For oxygen, round that off, 16.0. And you should know how to do that. So for every 1 mole of CO2, you need here the molecular weight of CO2. The molecular weight of CO2, carbon dioxide, by the way, that's the main gas in your burps and the little bubbles in pop and beer and champagne. So we have 1 carbon and 2 oxygen. Each carbon is 12.0. We saw that in the periodic table, the atomic weight. There are 2 oxygens, and each one is 16.0. And 1 times 12.0, 12.0, 2 times 16.0, 32.0. If I add them up, I get 44.0. I get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures. This is 1. This is 1. My answer has 1, so I can put it in here just like that. And now, before I pick this up, I shouldn't have picked it up, bad Dr. White, you check your units cancel out. Notice grams of CO2 divided by grams of CO2. Anything divided by itself equals number 1, cancels out. So these units are gone. I'm left with moles of CO2. Now I'll pick up my calculator, clear it. And it gives me this huge number. Not huge, a lot of significant figures that are really not correct for this problem. And don't forget 10 to the 0 would be just 1, so times 1. Now, this has how many significant figures? When you multiply and divide, your answer should have the same number of significant figures as the number with the fewest significant figures. In this case, both are 3, so you need to round this off to 3 significant figures. And somebody already beat me to it, but I'll do it. Keep the 1, keep the 4, keep the 0. Use the 2 to round off. That's 4 or less, so I'll drop that. And this is for step 1, how many moles of CO2. Now, I forgot to mention for the last problem, hold on, this is thirsty work. Moles always are. That when you're doing multiple calculations, step 1, 2, and 3 like this, there are 2 philosophies. One you round off at the very end, and one you round off at each step. I'm a round off at each step person, and I've done calculations, hundreds of thousands of dollars we're riding on being right, and it works. But I also can't say you should only use 1. On a test, not while we're doing the problem now, but on a test, I will calculate both ways, and sometimes they're the same, sometimes they're different at the very end. They're different, I'll accept either answer. All right, well, we've done step 1, but we have 2 more steps to go. And step 2 is convert moles of A to moles of B. And we just calculated A right here. So I'm going to help you out. And now it's your turn to convert this into moles of B. And I'll scroll up there because you'll need the balanced chemical equation. Hi, Veronica.
Hello.
Glad you could join. I forgot to say hello to Nubia. Also, glad you could join.
Hi, Dr. White.
Hi. All right, what we're doing is step number 2 of this problem. And that's converting moles of A, that's the CO2, to moles of B. And you've got to look at this and what's moles of B. Hint? Big hint? And we're going to go actually a little past our, oh, we got time. I think we might finish before the first break. The only break. When I teach 12-12 in the summer, we go from 9 until 1 o'clock. That's a long day. Yep. Twice a week. All right. What are we trying to get to? Moles of B. How do we know what that is? That's whatever molecule we're trying to get our answer to. Grams of C3H8, propane. So we want to go to moles of C3H8 propane. And now we'll use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top. The units, whatever we're trying to get rid of, goes underneath the units. And here we have moles of C3H8 propane. And underneath we have moles of carbon dioxide, CO2. And where do we get a relationship between moles of CO2 and moles of C3H8? From our balanced chemical equation. Remember, the coefficients give us molar relationships. And when there's no number, it's the number 1. What this really tells us is 1 mole of C3H8 reacts with 8 moles of oxygen to make 3 moles of CO2, carbon dioxide, and 4 moles of water. And all we need is for every 1 mole of C3H8, you make 3 moles of CO2. With that in mind, for every 1 mole of C3H8, we make 3 moles of CO2. And that's where we get those numbers. Again, from the molar, from the coefficients, the number in front of the chemical formula in a balanced chemical equation gives you molar relationships. When there's no number, it's the number 1. So this again tells us for every 1 mole of C3H8, we have 3 moles of CO2. And that's where I got those numbers. And now moles of CO2 divided by moles of CO2 cancel out, because anything divided by itself equals the number 1, cancels out, and I'm left with moles of C3H8, which is what I want. And now I can pick up my calculator, clear it, 1.40 times 1 divided by 3, I get this number. .6666, and it keeps on going, more knows, but I'll just do that, times 10 to the minus 1. If we look at a multiplication division, you get the same number of significant figures, the multiplication or division as the number that your answer should have as the number you're multiplying dividing. This is 3 significant figures. These are coefficients which are exact numbers. So the only number we use to find out our answer significant figure, this step, is 3 significant figures. Keep the 4, keep the 6, keep the 6. Use the next one to round off. Is that 5 or higher? Yep. So I'm going to drop this, increase that by 1, and my step 2 answer is 4.67 times 10 to the minus 1 moles of C3H8. Are we done? I don't know. Well, I got moles of C3H8. Oh, look, we're trying to get grams of that. So now we need step number 3. And in the past, students would have to memorize this. You'll be given that. And step 3 is moles of B to mass of B. Whenever you see the word mass, think grams. So now I'll do step number 3, moles of B to grams of B. What's B? What we just calculated in step 2, 4.67 times 10 to the minus 1 moles of C3H8. And I'm going to let you set up what's the ratio. I'm going to help you out a little and put the units here. And what units do you want your answer in? And then I'll do it. Your turn. Don't forget, fill in the units on top and bottom of the ratio also. All right, my turn. What are we trying to get to? Grams of B. What's B? Propane. C3H8. And now you'll use your good buddy, mine too, your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio, unit-wise. Whatever we're trying to get rid of, I don't want moles of C3H8, my answer, goes underneath. And I'll write that in. And where do I find a relationship between grams of a compound and moles of a compound? Well, in case you forgot, let's peek at important information, test 2. The 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. And if we go and look at our favorite neighborhood, friendly neighborhood periodic table, we have carbon at 12.0. Remember, use 3 significant figures for all atomic weights, and hydrogen is 1.01. So I will need, for every 1 mole of C3H8, I'll need the molecular weight of C3H8. And the molecular weight of any compound is the sum of all atomic weights. There's 3 carbon and 8 hydrogen. Each carbon is 12.0 atomic weight. Each hydrogen is 1.01 atomic weight. This is 36.0. This is 8.08. This would be 44.08. Hopefully I did my math correctly. If not, somebody better correct me. Tell me you made a mistake. I don't think I did. And this has 1 significant figure to the right of the decimal. All numbers are significant, including decimals in this case, and 2 to the right. And the question is, what's the proper number of significant figures to the right of decimal when you're doing an addition? And the answer is the number with the lowest significant figures to the right of the decimal is the number of significant figures you should have, which is 1. Keep the 0. Use the 8 to round off. Is that 4 or less or 5 or higher? And 5 or higher. Drop that. Increase the number in front by 1. So the correct answer for the molecular weight of C3H8 propane is 44.1 grams. And now I will look and see moles of C3H8 divided by moles of C3H8. Anything divided by itself equals the number 1 and cancels out. That cancels out. I'm left with grams of C3H8. And now I can pick up my calculator. Now to get to the 10 to the minus 1, after you put 4.67, at least on this one, blue double E, whoops, hold on. Blue double E, and then use the minus sign here, not over here. Use this one, which I did, and I'll put in a 1 times 44.1, and my calculator gives me this answer. And you get the same number of significant figures to answer as the number you're multiplying and dividing with the fewest significant figures. This is 3 significant figures. This is 3 significant figures. This is an exact number. So this you should round off to 3 significant figures. I'll give you 6 seconds, 2 times 3, to answer that, and then I will. Your turn. All right. Well, keep the 2, keep the 0, keep the 5. Use the 9 to round off. Is that 4 or greater, 4 or less, or 5 or greater? And the answer is 5 or greater. Drop that. Increases by 1. That's how you round off. And this is 2.06 times 10 to the 1 grams of C3H8. And that's your answer. Now you know why it's 10 points. And now you know why it's time to take a break. With that, let's take a break, and I'll see you in 5 minutes. I can get up and stretch. Let's continue. First, a quick commercial from your host, me, Dr. White. Don't forget, this Thursday, I'll be doing test number 2. Also, tomorrow, Tuesday, I will do my world famous review for the next test. In this case, it's test number 2. And I'll also go through the practice problems for chapter 5, part 1. Plus, we'll also do the lab. With that, let's get back to work. And as I've been showing you, 1 mole of a compound equals molecular weight, and the the coefficients of a balanced chemical equation represents molar quantities. Now, I'm going to turn the switch off, click for this one, and there's something called percent composition, and that's the mass of percent of each element. And that's determined by the mass of an element divided by the molecular weight, that's also known as molar mass, of the compound it's in. And this is a very useful number to have to help identify or prove the identification of certain compounds. And for my PhD thesis, I had about 150 new compounds that I made for my PhD research, thesis research. And each one of those, because it's organic chemistry, remember, I'm an organic chemist, you send out for what's called CH&N analysis. They have instruments that measure this. And then based on what you think the molecule is, you do this calculation for carbon, hydrogen, and nitrogen, and they should be the same. Mine worked. That was a lot of work, too. All right, now, if I look at this, oh no. Let's see if we can see this. Well, we're at the end of chapter 5, part 1. I have now covered everything for test number 2. I try and finish a couple days in advance. I actually finished it last Thursday when I did the practice problems for the 3-step. But officially, I have finished the material for for test number 2. Hold on. For test number 2, not step. Did you get it? Yep. Oh, it's Bad Humor Monday. All right, with that in mind, we will now go into chapter 6. Chapter 6 that I'm going to start covering will not be on test 2, but it will be on test 3. So let me close that. Open that, and chapter 6 deals with gases. Now, what's a gas? Well, that's something that has indefinite shape and indefinite volume. I'd say a question. One of your colleagues asked chapter 5, part 2. Good news, I'm not going to cheat you out of that. We're going to do that later on. One of the things, and let me go full screen. One of the things about this book, which you didn't have to buy, but I follow the chapter, or at least what's in the book, is the order that the author has it, chapters 1, 2, 3, 4, 5, different parts, is not the best way to help you learn chemistry. It stinks. Anyways, yep, stinks. And so I'm jumping around. We'll do part 1, chapter 5, like we did. We're going to do chapter 6, and later on, we will come back at the right time to do chapter 5, part 2. I'm not going to cheat you out anything. All right, now, When we think about gases, right now you're surrounded by a gas, just like I am. If you're not, well, you're not on our planet, or you're not an Earthling. I hope you're all Earthlings from the planet Earth. But anyways, any Martians, email me. But anyways, you're breathing a gas, actually a mixture of gases, but it's gas. And if you look in your car engine, in the cylinders that make the car go in the engine, that's run when you have the gasoline as a gas. So why learn about gases? Well, you'll learn in a little while. Maybe not today, but this week. So when we talk about gases, there's something called the kinetic molecular theory of gases. Now, I would like you to be aware of this, but I will not. Well, I can. I can ask you about this on test number 3. I can ask you, give me one aspect of the kinetic molecular theory of gases. So let's talk about it. A gas consists of small particles, atoms or molecules, that are moving randomly with rapid velocity. Velocity is speed and direction. Speed alone is just a number. Velocity is direction. If you've had it, which I have, that's a vector. But we won't relax. We won't do vectors in here. So right now, they're molecules of oxygen, nitrogen, zooming all around fast. Now, the attractive forces between the gases are non-existent because they're moving around very fast. And then number 3, well, you'll understand why those attractive forces can be neglected. The average actual volume occupied by the gas molecules is extremely small compared to the volume that the gas occupies. What does that mean? Well, in a solid, you got the atoms as close together as you can get. When you go to a liquid, they're close together, but farther apart. When you go to a gas, they're way apart, way apart. Instead of like this, they're way apart. So between them is a lot of empty space. If you compress them all together, the volume of the actual molecules is very tiny because there's great spaces between them. And the average kinetic energy of the gas molecules, that's how fast it's zooming, and is proportional to and this is important, the Kelvin temperature. When we talk about gases, we use Kelvin temperatures a lot. And finally, gas particles are in constant motion, moving rapidly in straight lines. Now, when you think about gases, their key physical properties, chemists, and even you, a non-chemist, measure. One of those is pressure. Another one is volume, how much. Another one is temperature. And the last one is amount, which is weight, grams, but that's usually converted to moles, which you know how to do, I hope. So these are the key properties of gases, and I'll never, ever ask on a test, what are the key properties of gases? Nope, won't do that. But let's talk about them. And the first one I'd like to talk about is gas pressure. Now, switches off for the slide. What's pressure? Well, that's the force applied per unit area. Another way is saying the total force of a surface divided by the area of that surface, and we call that pressure. I will never, ever ask you to use this formula. I don't use it, but I know it. Now, it turns out one of the most important pressures is the atmospheric pressure, which you ignore most of the time. Right now, since the time you were born, you've been in a atmosphere, the gas around us, pushing on you. There's a pressure all over here. And you're always surrounded when you're on our planet. And remember, I asked the first day, was anybody planning on leaving our planet, Earth? And nobody was, so I can say that. You're being pushed all over. And we call that atmospheric pressure. And turns out that's a very important concept and a very important measurement. And the device to measure atmospheric pressure is called a barometer. And the atmospheric pressure is measured in one unit called millimeters of mercury. Millimeters, that's the distance, Hg, chemical symbol for mercury. Now, 1 millimeter of mercury, Hg, is also equal to 1 torr. 1 millimeter of mercury equal to 1 torr. And torr, T-O-R-R, is shortened of the name of the Italian scientist. I don't even think they called them chemists back then, who invented the barometer, a way of measuring atmospheric pressure. And that was the Italian scientist Torricelli. Hang in there while I find a good picture. All right, does everybody see on your screen? Let me make sure. On the right, underneath where it says study.com, let's see if I can pull up a big picture from them. Nope, they don't want to. All right, this is the original barometer that Torricelli invented. And at the bottom, he had a dish of mercury. At room temperature, mercury is a liquid metal. And what he did was stick a tube that had a vacuum in it into the pool of mercury. And he measured the height that the mercury went up the vacuum tube from the level of the mercury here to the level up here. And he measured it in the metric system, millimeters of mercury. And while we're here, and here we have a picture of Torricelli. I hope I'm pronouncing it correctly. And that was back in, wow, I thought it was 1700. Well, I was only off by about 60 years, 1643. And if you notice, he did it in Italy. And here they show the original one. And I used to work in labs where we had these until people realized how toxic mercury is, and you no longer find these type of barometers. But that's a way of measuring the atmospheric pressure. Now, how important is atmospheric pressure? Well, let's go. My favorite weather website is the Weather Underground. If we look at Glen Ellen, where the main campus of COD is, you can see on the screen the Weather Underground for Glen Ellen. And if we scroll down, we'll see here pressure. And that's in inches because we're in the United States. Instead of millimeters of mercury, we use it for our weather inches. I won't be using inches in this class, but that tells us when there's a storm front coming through, the barometric pressure decreases. When it's high, it's a sunny, clear, good weather. No, I'm not really a weatherman, but I learned that much. So we have this measurement called pressure, millimeters of mercury. And 1 millimeter mercury equals 1 torr. And bear with me because I have to open up something. All right. That's not what I want. Hold on 1 second. There we go. All right, now, time for Dr. White to get subtle. One millimeter mercury equals 1 torr. Now, this will be given to you in test 3, important information, but you should be familiar with this. And when we talk about pressure, turns out for a lot of things we do in chemistry, an important pressure is what is the atmospheric pressure at sea level? And the reason why is the higher you are on our planet, the difference the atmospheric pressure is. It gets lower. So you get into outer space when it's almost zero, if not zero. So by definition, when there are no storms coming through at sea level, the atmospheric pressure is 760 millimeters of mercury, Hg. This is a defined number. This is an exact number. Since 1 millimeter mercury equals 1 torr, this also means 760 millimeters of mercury equals 760 torr. Now, it turns out there's another very important unit we measure pressure in, and that's called the atmosphere. And the atmosphere units of pressure is noted by ATM. So you should also know, so it even says it on the slide, but you should know 760 millimeters of mercury equals 760 torr, and 760 torr or millimeters of mercury equal 1 atmosphere. Know this. Well, I even wrote it on this slide, but you don't have to memorize this. In the past, I would ask you to memorize it. Now you'll see here 670 torr equals 670 millimeters of mercury equals 1 atmosphere. So what time, or before we get into it, there are other pressure units that we're not going to cover in this class. For inches of mercury, 29.9 inches of mercury equal 1 atmosphere at sea level. Another one is PSI, pounds per square inch. That's a pressure unit. And 14.7 PSI, pounds per square inch, equal 1 atmosphere. Now, where do you use PSI? Your car tires. You have car tires, which I think all of you do. There's gas in there that keeps them inflated. And hopefully you check yours at least once a month. I do. I have an older car that I have to use a gauge. I don't have the actual sensors like the newer cars have, but you should check it and fill it up. Otherwise, you'll be driving around on flat tires and you'll destroy your tires. And it's also won't stay straight when you're trying to drive if your car pressure tires. And when you go to a gas station to measure your car pressure tires, or find one that has a compressor, and I'll teach you about a compressor later, the device that puts air in there, your car tires, at least mine, is at 35 PSI, a little more than twice atmospheric pressure. And I'll teach you why that is later in this chapter. Again, these other pressure units we will not use in this class. Now it's practice time for pressure. And let's do some of these. How many torr is 452 millimeters of mercury? I think it was the number I used. If not, we can still use it. So 3 points each. How many torr is 465 millimeters of mercury? Well, what are you being asked to find? Torr. What are you given? 465 millimeters of mercury. And this is the only number we have to start with, so I will. And what units are we trying to get to? Torr. Remember, both of these are measure of pressure, which we do for gas. And now we'll use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And where do I get these numbers? Well, you look at important information, test number 3. Remember, this is material we're covering now for test number 3. And 1 millimeter mercury equals 1 torr, or really, I'm not going to have this on here. What I will have is this, 760 torr equals 760 millimeters of mercury equal 1 atmosphere. These are all exact numbers. This is a definition. So every 760 torr is 760 millimeters of mercury. And now notice millimeters of mercury divided by millimeters of mercury cancel out. I'm left with torr, this divided by this, number 1. So this is what I get. Now, don't forget, when you do multiplication division on test number 3, like 2, we'll say, please use proper significant figures for all calculated answers. So this is 3 significant figures. This is an exact number. This is an exact number. And therefore, our answer is 3 significant figures. We're done. And remember, how did we do this? 760 millimeters of mercury equals 760 torr equal 1 atmosphere, ATM. And these are all exact numbers. This is a definition. By definition, this has been set up. All right, let's do another one. And I'm going to let you try this one on your own. Why don't you set it up? I've given you this, which will help, which will be on important information, test number 3. Your turn. And when you're done, don't forget to vote yes, please. All right, my turn because everybody's done. So what are we being asked to find? Millimeters of mercury. What are we given? 751.8 torr. Remember, torr and millimeters of mercury, mmHg, are pressure units. So the only number I have to start with is this. If I had a ratio, what am I trying to get my answer units in? Right here. And now it's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top of that ratio. Whatever we're trying to get rid of goes underneath. And I'll write it in. And up here, notice for every 760 millimeters of mercury, there's 760 torr. And the number, if I just do the math real quick, 760 divided by 760 is 1. 1 times this, 751.8 would be 751.8. When you do a multiplication division, you get the same number of significant figures in your answer as the number that has the fewest significant figures you're multiplying and dividing by. This is 4 significant figures. This is an exact number. This is a whole definition. And this is an exact number. Therefore, this is the only number you have, and our answer has 4 significant figures. So the answer would be 751.8 millimeters of mercury. Let's continue on with our practice. And the question is, and I'll do this one, let you try one. I think we might have time. How many ATM is 851.6 torr? We're trying to find ATM. We're given this number. These are both pressure units, which is why we're talking about them. So the only number I have to start with is this. If I had a ratio, what units do I want my answer to be in? And the answer is atmospheres, ATM. And now I'll use my good buddy, my good friend, hopefully yours too, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And now I'll write that in. Oops, wrong color. Let's try and get the right color. And where do I get these numbers? You'll be given this in important information, test number 3, 1 atmosphere is 760 torr. And now before I pick up my calculator, notice torr divided by torr, anything divided by self equals the number 1. This cancels out. I'm going to pick up my calculator now, clear it. 851.6 divided by 760. And my calculator happily gives me this number. And the question is that the right number to put down without me marking it wrong or taking off a point? And it would be, because you get the same number of significant figures in your answer as the number you're multiplying and dividing by. And the number that has the lowest significant figures that you're multiplying and dividing by, 1, 2, 3, 4 significant figures. Now, this is important. The 1 is an exact number. The 760 is an exact number. Therefore, the only number you use to determine for this calculation how many significant figures is 4 significant figures. And we'll keep the 1, keep the 1, keep the 2, keep the 5. That's my 4. Keep the 5. I got that. Let me start again. Keep the 1, keep the 1, keep the 2, keep the 0. I skipped that. Don't tell anybody. And you use this to round off. Is that 5 or more? Yes. So I'm going to drop this and all these numbers afterward. increase this by 1, and the answer would be 1.121 atmospheres, or you could have written it this way too. Remember, 10 to the 0 equals the number 1. And that's how you do it. So this new pressure units you are learning, and that's 760 millimeters of mercury equals 760 torr equal 1 atmosphere. And you can convert from one unit to another using that. If I look at the clock, oh no, we're out of time. Time flies when you're having fun with chemistry and Dr. White. I hope it does for you. All right, let me remind you, tonight I will have my office hours from 7 to 8 on Zoom. If you need help, stop by, say hello, and ask for help. If you can't make it to my office hours and you really need help, email me and I'll see if we can set up a Zoom meeting so I can help you. Also, don't forget, hand in your labs, please. They're easy points, but if you don't hand it in, you get 0, 0, zip. And that's going to really hurt your grade. I saw that last semester, a few students who didn't. And it really hurt their grades. I didn't feel good having to do that. But I kept on telling them, hand in your labs, and they didn't. And I have to do what's in my syllabus. So with that, don't forget, Thursday, I'll be giving test number 2. The best way to study for test number 2 is 1, watch the videos I've done, and 2, do the practice problems for chapter 4. And tomorrow I'll go through it for chapter 5, part 1. And with that, I'm done for today, other than my office hour. I also have to put out my garbage right now because I have Tuesday morning garbage pickup where I live. Ooh, that was personal. Shouldn't have told you that. No, I can't. With that, I'll say, gang gesund. Goodbye. I stole that from Granny and the Beverly Hillbillies. Goodbye.